Okay, so I think we can start. It's 6 o'clock, so welcome everyone to another AWS user group, Krakow edition, and we are again online. We have really cool guests, but before jumping into that, so few things first. So maybe you are wondering, who am I? So hi everyone, I'm Szymon. You're probably wondering where is Maciek. He's basically at work has some duties, so I'm his deputy, and I'm helping sometimes him to organize this cool event. So we have today really deep dive into really technical topics. We will talk about testing infrastructure as a code, and we will talk some stuff around EKS and spot instances. But before going and introducing our presenters, I want to say a few things about pizza. So you are probably used to having pizza right now, and I have a surprise for you. Today we don't have a pizza because you are probably full of donuts already. I am definitely. I had four donuts, and the level of sugar is quite high. So we were figuring out what else we can do. So basically, we presented or agreed to give you a prize, and you can get it just filling a quiz. I will post a link to that quiz in a chat. So just please fill it. It will. There are some technical questions there. If you will be listening, you will know the answer from our presenters. But guess what? You don't need to answer correctly to get the prize. It's a guarantee. So everyone who actually just fill the questionnaire will get a 15% discount on training on the Szkoła Chmury side. And if you actually will know the answer and you will listen carefully, you will be able to get other prizes. So we have also like 10 shirts to get distributed from Chmurowisko. And we have 3 coupons for AWS shop. Like this is some kind of brand shop where you can buy cool AWS gadgets. And we have 3 coupons for $25. So if you want, you can just fill the questionnaire and win the prize. Okay. So now we can jump into our cool guests and presenters. First, Maciej Raszplewicz will talk about infrastructure as a code and testing it, and this is really interesting topic. Actually, I'm personally interested about that because we at work struggle a bit with that, to be honest. So I'm hoping to get some insight as well. So you can ask questions on the chat. Keep in mind that there is a delay in our system, so we will maybe answer them like half a minute later. No worries. But the question, you can just type them on the chat, and we will take a look on them after each presentation and try to answer. Okay, so that's enough from my side. Let's welcome on the stage Maciej. You can start sharing your screen. Okay. And yeah, stage is yours.
Okay, probably can see my presentation now. I hope.
Yes.
I will say something about testing in infrastructure as code as Shimon said, it's not as obvious topic as testing normal applications. So first of all, if you don't write tests, they will not fail. But should you write them? I think you should. About me, I have over 15 years of experience in IT. I worked on almost every role as an architect. I am a programmer. I can write code in several languages like Java, C#, Golang, TypeScript. Currently, I am a co-founder and CTO at DevOps. It's a DevOps startup, and also consultant at Chmurowisko. Today's presentations will be about tests. So we will briefly introduce the test topics and tell something about some theory. Then I will show Terra test, then our custom mini framework, and then I will tell something more about other infrastructure as code tools, and maybe what is the future of infrastructure as code. I think is the future. So why automated tests? There are multiple reasons, but main are avoiding regression problems. So if you change your code, you probably, if you have automated tests, you probably will discover all the problems with your code. The second is faster development. You should write tests for yourself to have very fast feedback loop to develop faster, because nothing is as quick as unit tests. Nothing checks your code as fast as unit tests. And of course, better code quality, and many more, I think, but these are, for me, the most important aspects. And one more thing, the test pyramid. This is something that is drawn in multiple ways. It can be UI or acceptance tests on top, but unit tests are always on the bottom of the test pyramid. Why? Because unit tests are very, very fast and reliable. So you are almost sure that they will execute every time properly, and they are really fast. You can execute hundreds of thousands unit tests in a second. So it's really fast. That's why you will probably want to have a lot of unit tests to check your code to develop fast. And then there are integration or service tests and UR or acceptance tests. They are more fragile. You are probably going to have them, but have them less. I think business people want to have a lot of acceptance or UI tests, but it's quite not possible because they are slow and it's really they are often fragile and they depend on network, on other systems, etc. The problem that we'll be solving today in my examples will be very simple S3 bucket module, but let's think that our company told us to create the module which will be reusable for all our infrastructures as code scripts or code, and that it should have constant naming convention, and there are some problems with the S3 bucket naming. You cannot repeat names, even if you are other customer, you have another AWS account, you can't have a bucket with the same name. And there is a limit of 63 characters. This is maximum length of S3 bucket name. So let's show you the module Terraform and check how you can test it in TerraTest. You can see my IDE. Okay. So we'll enter presentation mode, and I will show the Terraform code here. The code is really simple. This is our Terraform S3 bucket resource. There are few local variables, and what is the input of our module is here. We've got AWS region, component name, and environment name, application name, bucket purpose. Like it can be like pictures, documents, etc. And there is a flag also here. It's called use local stack because we also support local stack. It doesn't matter here on the presentation, but you can see it on GitHub if you want. I will share the link later, or maybe Shimon will know. Okay, so then when we have this Terraform module, we can write tests in TerraTest. But about TerraTest, you will probably have to write some code in Golang to test the code. No, not all programmers know how to write the code in Golang. Myself, I have learned it. I think a few months or a little bit more than 1 year ago. So I'm quite a fresh Golang programmer. So we also wanted to have possibility to write tests in some other language, but I will show TerraTest now. Basically, we are declaring here environment name. It's random, something random. AWS region where we run it. There are Terraform variables like in our module. We are copying our module to some temporary folder just to have state files somewhere else than everything. And here we are configuring TerraTest, then doing destroy after the test will run, then init apply, and TerraTest has built-in assertions. So this is basically the simplest possible TerraTest test written in TerraTest. Let's check it. It is actually creating the bucket, so it's not a unit test. It's an integration test, so we have to wait. If it's S3 bucket, it's okay because it's quite fast. But when it comes to RDS database, it's anything else, it's not that good because you have to wait for like a few minutes or more than 10 minutes even when it comes to Elasticsearch or something like that. So we can see that it worked. We had it actually created this S3 bucket, just checked if it exists, and that's all. But what about our naming convention? I said that when we have some name that will be more than 63 characters, our code will fail. So we have to do something with that. Now let's switch back to the code. So If it's more than 63 characters, we are just doing some checksum from the bucket name and do substring. So that's all, and we are sure that it will not be more than 63 characters. And then we want to test also this behavior. I will switch to a little bit more complicated test. I advise you to do, when you write tests in Golang, you should really create a table-driven or data-driven tests like this one, where you just create some data structure and tell your here what are your variables and what is the expected result, and almost all the code from the test before is inside a loop here. So we have here we are not repeating all the tests, we are just parameterizing it and have the data-driven test. The good thing is that it's parallel also. It's very important to reassign variables here because of parallelism. It's something about Go language. The Go routine here will just have the right values, but it's not that important now. And let's try it and run it here. We will see that we've got two tests. One is short name, one is long name, like here. Again, it's not a unit test. It's an integration test. We are actually running tests against the real AWS account. And it works. Okay, so but what if you don't want to write your tests in Golang? We have prepared something that we call a mini framework. It's really not that. It's quite simple, and you can write similar things in multiple programming languages. So for me, if you want to test your infrastructure as code, you can use any programming language and any unit testing framework you want, and just call the actual Terraform or CDK binary. I will show the Terraform example again and go to the CDK, because when it comes to unit testing, there will be some difference, and it's very important. Okay, so let's show the test in our mini framework and again test this Terraform code. We'll switch to Java now because, okay, so Spock is in Groovy, but it's Java world. And these are the files of our framework. I will not explain them. They are on our GitHub. If you want to use them, just please use them, copy whatever you want, and even rewrite in another language. You are free to do that. I think they are not that. They are quite simple, so you will be able to do that in one day, I think, to create a similar framework for you. Okay, and let's show the test. Here, this is just different programming language, but it's similar here. We've got variables here. We've got some method to deploy this Terraform module. Just check if bucket exists. Here we had to actually write this check in using AWS SDK, because we don't have assertions like in Terratest, but it's not that hard to do assertions in AWS SDK in your programming language of your choice. So after that, we'll clean up, and again here we will test multiple steps here, like it will be short name and long name, and we'll expect short name and some hash sum of long name as bucket names. Let's run it. It should be, I think, no, not this one. Okay, let's run it. And again, we are waiting like for I think about 1 minute, 30 seconds for the first one, and 30 seconds for the second one. And should we wait for our test to complete? We'll be probably bored and go to and drink some coffee or something when we are forced to wait for to check our code. We lose our focus. And that's why I think it's better to have unit tests for all that is possible to test with unit tests, and then have some integrations or acceptance tests for other things. Okay, so the tests are have passed now. We are testing the same Terraform module as TerraTest did, and we did it in another programming language. It's really easy to write a framework like that, and I think if you don't like or don't know Golang, you should just write this kind of framework yourself, or take my code and copy it. Okay, but can we do really really unit tests and don't wait a lot for all the infrastructure? I thought that Terraform is one of maybe not the only infrastructure as code, but I thought it's the best, and you will probably think when somebody tells you something about infrastructure as code, I think you will probably think about Terraform, but this is not the only tool, and I was surprised when I discovered that there are frameworks like AWS Cdk or Pulumi, which is also very good, but I will focus on AWS Cdk now. And you are able to write your infrastructure as code in a real general purpose programming language, which is really good. But of course, I don't mean that Terraform is bad, but depends on your team. It depends on if you have developers in your team. But if you don't, if you haven't tried AWS Cdk or Pulumi, you should at least try it. Okay. So I will show you some introduction about AWS Cdk now, how it works, because I don't know that not everybody knows it, how it is different from using SDK. So we'll check out some CDK example branch and go to our code again. Okay, so if you use SDK and want to create your S3 bucket, you are doing some imperative code like here, just calling the client method create bucket. All right, it works. We have this bucket. Let's delete it. Okay, again, if we change the name, it will create another one. If you want to delete the bucket, we have to call delete method. So let's delete it because we don't have. We want to have fresh and clean situation. But when we want to do it declaratively, we probably use some infrastructure as code tool like Terraform, but we can also use AWS Cdk. And this is the simple CDK code for creating S3 bucket. We've got just to create using constructor the bucket object, provide name. Here we are going to add remover policy because we want to destroy the bucket on the destroy just for the presentation. And just fill the bucket name. Let's try it. So we'll use CDK deploy. Underneath it is creating CloudFormation templates. So it's using CloudFormation. So we can also see in our AWS console that it uses actual CloudFormation templates. It maps this Java code or another programming language code to CloudFormation stack and just deploys it. CDK supports JavaScript, TypeScript, Java, C#, and Python, as far as I know. So you can use multiple programming languages. Just choose one. Go is not supported now, but others are. Okay, so it has created our S3 bucket. Let's check if it exists now. Oh, okay, I have to log in again. Just wait a moment. Okay. We have it here. So we have this S3 bucket created by AWS CDK, but again we want to clean it up. We'll destroy it and show destroy, not destroy, and show you how you can test the code. Okay, destroyed. Let's switch to master branch again. The master branch is on our GitHub. We'll give you a link to that. Again, we are on master branch, and we can just show you. I can just show you how to code our requirements in using Java, because it's not CDK specific. It's just Java. We've got our algorithm, which was written in Terraform, here rewritten to Java. And we are just concatenating the name. And if the bucket name length is more than maximum name, maximum size, like 63 characters, we are just doing some checksum of the bucket name and substring of it. So that the code is, for me, it's much cleaner than in Terraform, but who likes what? And now we can test. We have to test again if our module works, but we don't have to test all the all the names. We can test just one if our module works, because we will create unit tests for other things. So we are going to create integration tests for one simple case, the most characteristic one or something like that, and test all the other things using unit tests. So tests as much as you can in unit tests. Again, I'm running create S3 bucket test here. It is actually calling CDK binary underneath. This is also our mini framework. Okay. It's destroying after, because here in cleanup we are destroying the bucket. Just you have checked if it exists, okay, and that's great. We have integration test of our code, but we are not testing our naming convention here, but just testing if our module works, and we will test our naming convention here in unit test. Why is it better? Because here we are just testing what we want, and it works like this, 93 milliseconds. Okay, we want to add some more cases here, like anything here, just to show you how it works. Maybe this one will fail. Again, let's run it. Okay, it's 100 milliseconds, 160 milliseconds now. So it's really, really fast. Nothing will check your code as fast as unit test does. You are not waiting for the test to run. You are not waiting for AWS or anything else. Just going and testing your code locally, and you can use those tests in your CI/CD, and it will be very simple. Your CI/CD builds will not require any AWS accounts or something else. Just run your local tests, and it can really test a lot of your code if you create your infrastructure as code in a general purpose programming language. Okay, so here we have this unit test written. And what about Terraform? Can we write unit tests for Terraform? I don't think so, but we can do one more thing. I will not show the exact result, but we can use local stack, which will speed up a little bit your tests, especially when it is creating something that is it takes long to create, like RDS or something else, Elasticsearch, Kafka, anything that takes long to create. But local stack doesn't support everything. It is not exactly the same as real AWS. So you will probably develop using local stack, and then later run also your test using something else. Some tips to use local stack. You can configure your AWS provider in Terraform and have some variable like this one, Boolean variable use local stack. And here you will have your endpoint to local stack, and there is some hack to use this endpoint if you use local stack, and don't use just use the default one if you don't use local stack. So the dynamic here in Terraform here, and one more thing, you cannot, if you want to use local stack and Terra test, it's possible, but you can't use Terra test assertions now. They have GitHub issue open, and they are working on that. I know that I have some. I'm watching this issue and know that they are working on that, but they haven't finished. So you can't use Terra test with local stack. You can use assertions. You can use Terra test, but you will have to write your own assertions, like we did here in for Terraform or CDK in our Spock-based tests, like this one. Okay, so let's move. Okay, so which one should you use, Terraform or CDK? for me, the choice is obvious, but not for everybody. It doesn't. If it suits me, it doesn't mean that it will be the best choice for you. It depends on your team, really. But I advise you to just try CDK, just try or Pulumi, and try how it works. Because if you have developer skills, it will be much faster, much easier to create infrastructure as code in CDK, and you will have ability to just use external libraries, like for Java you will have normal unit tests, you will have refactoring options like extracting some classes, variables, functions, whatever you want. I even have one function which is responsible for almost every naming convention of my AWS resource. But about AWS CDK, again, Terraform supports multiple clouds. AWS CDK supports now it supports only AWS, but there are projects like CDK Terraform, which is, I think, backed by HashiCorp and other flavors of CDK. So probably in the near future you will be able to create code in another flavor in CDK TF and just run it to Terraform underneath. You can use CloudFormation, of course, if you want, or other similar tools for Azure or other clouds. And there is Pulumi, which I think is also very good, but I'm a Java programmer, so it doesn't support Java now, and that's why we have chosen AWS CDK, not Pulumi, but I know it's great also. I did some project using TypeScript in Pulumi, and it works, and it wasn't too hard to create all the infrastructure in Pulumi, and it's quite similar to CDK, but it uses Terraform providers underneath. So it supports more clouds, not only AWS. And the future of infrastructure as code, I think and I hope that it will be normal general purpose programming languages like Java, TypeScript, Python, whatever. But there are some issues with these tools. Those two issues here are about automation and running those tools from code. You cannot run AWS CDK without its binary. It will be much better to use it from your code from tests without need to use binary. But it's not possible now. Maybe it will be possible in future. For Pulumi, it's a little bit better because they are working on automation support. So just check this link, and maybe they will finish it soon. Okay, so maybe let's move to questions. I can see that there are a lot of comments here.
Yeah. So thanks, Maciej. That was a really great presentation. I enjoy it. Yeah, that's really cool. We have already a lot of comments actually. So let me maybe read a few of them, like those that are questions. Few of them I think were already answered, but let's see.
Okay.
So first, what I can see, if this will be recorded, yes, it will be available on YouTube. And then we have a question from Bartuszak, I think. it is not an anti-pattern to use a local stack for any kind of tests?
I think that it's not anti-pattern to use it to develop the tests, but you should really run your tests against real cloud also. This is my answer for that. Because if you can develop your tests faster, it is good, but you are never sure that it will work against real cloud. So you will have to, like maybe in your CI/CD, run it again.
Yeah. Okay, thanks. Then another question is for V. Is it possible to have TerraTest pipeline as a code? Please share some insights.
You mean pipeline like in CI/CD, like in Jenkins or something like that? Maybe I will answer this question in context of Jenkins. I think you can do anything. You can just run your code, but when you have this cleanup code, when you destroy your cloud resources and you have some random names inside, we'll probably be able to run it also in CI/CD, and it will work. And I hope to answer your question, but I'm not sure.
Yeah, from what I understand, that was the question. So I think that's good. And we have also like a comment from Evgeny about the CloudFormation. CloudFormation acts very weirdly with big stacks or related stacks. Maybe it's better now, but like 2 years ago, it used to bring a lot of pain in my life. Do you share the same experience with CloudFormation?
Not exactly, because I use CDK mainly. You know, it uses CloudFormations underneath, and maybe I'm lucky. It behaves okay. Maybe my stacks are not as big as yours, and when I'm correlating my stacks, I'm using just Java features. So like when I want to use a resource created by another stack, I just use Java, nothing CloudFormation related. So maybe that's the answer. My stacks are not as big as yours, maybe.
Okay. Thanks, Maciej. Let me see if there are any other questions. We have a lot of comments actually.
We read them, but not now, maybe.
Yeah. So if you have any other questions, just post them. We can have a look and maybe answer them as well later. And thanks again, Maciej, for your presentation.
One more comment. Chmurowisko is organizing this training, which is you will have discount if you take this. If you post answer to these questions, and I will be probably a trainer in one of them. So I invite you also to take those courses from Szkoła Chmury.
Yep. Thanks. So I will post the links for that quiz again in the chat in a minute. So if you missed it in somewhere in the comments, don't worry. I will post it. And as I said before, everyone wins. The answers doesn't have to be correct to get the discount for that training that Maciej was explaining. Okay. So thanks again. And that's time for our next presenter. So let me introduce Sandeep. Just a second. Yeah. Hello, Sandeep. The next topic, it's also a really interesting, and it will be about EKS and spot instances. So another hot topic, and more about how we can save some money using spot instances and running our applications on EKS. So I'm not taking much more time. Thanks, and stage is yours. You can start sharing, Sandeep.
Perfect. I think, let me know when you can see it. Hello?
Yes, I can.
Okay.
I can see. I hope everyone else, you can also type on chat.
Perfect.
Okay, thanks. You can go.
Thank you, Shimon. Yeah, thank you very much for the introduction, Shimon. So hello, good evening, everyone in Krakow, and of course, good morning for me. It's already quite late. I'll not take so much of time for you guys. I will try to go fast, but to be precise as much as possible. We will discuss today about the EKS with the spot instances, how we can use it, what are the methods we can put spot instances in our workloads for the EKS Kubernetes cluster, and how we can deploy them in specific nodes of spots. So of course, to save money, because these are 70 to 80% at lesser discount than the on-demand instances. So let's start with myself, Sandeep. I am a SRE right now in Thales, Singapore. It's a French company, very big one. And of course, yes, I was, most of you guys already know me. I was in Krakow some time ago. I just moved here. Right now I'm working on Azure, but I have pre-experience of AWS. My company right now have both hybrid cloud. So we have EKS clusters as well as Azure AKS clusters. So it's quite complicated here. And of course, right now, all these things that of course I'm digging into right now in career-wise. You can find me with the same name, Sandeep Lamba, whether it's GitHub, Twitter, or LinkedIn. It's very easy to find. Okay, let's start with how it goes. So I will start with the overview. What are the spot instances? Very precise. I will not go in detail because everyone knows AWS and knows about what are spots. I will try to give more time in number 2 and number 3. What are the features, how we can deploy spot instances with, what are the different operators in Kubernetes which we can use, and how to seed the Kubernetes cluster itself with the specific spot instances. So these two topics are very important. And of course, I will show you in the end how does it look like in a demo. So let's start with the spot instances. Everyone is aware of that. It's a spare compute that AWS have, and they want to give you for use because nobody is using at that time. The prices are, of course, 70 to 90% lesser than the on-demand prices. And actually depends on the demand and supply. There are many factors on which they depend. You can say the size of the instance, the family of the instance which you want, availability zones, and AWS regions. So say if you have a specific instance type in AWS region, the price of that instance is totally different in a specific region than the same instance type in another region, because again, it depends on the supply and demand. So the prices cannot be the same. And of course, if you want to optimize cost and if you want to fully use spot instances, especially for your stateless workloads in Kubernetes, it can save you a lot of money. So budget-wise, they are very okay, but of course, you need to handle them very precisely. How the AWS handles. So we need to understand what is the logic behind it and what AWS gives us about the spot instances and how we can handle it. So very easy. You can start a spot instance and say you have a spot instance, one specific size, it's available to you, but in a specific region, in a specific availability zone, you have a spot instance running. And all of a sudden, the requirement came from some of the company who says that I need 100 instances of that specific type in that availability zone. So what AWS will do if if he will not have that spare capacity, and he knows that I have some sports, so he will take out those sports. So maybe your workloads are running on those sport instances, so AWS will just take it. But it's not that right away the AWS will take it. It's not that easy. So AWS says that, okay, fine, you were using our sport instances. I'll give you a graceful time of 2 minutes. So within 2 minutes, do whatever you want to do with your workloads. And after 2 minutes, I will take this spare capacity because there are some other guys who are ready to pay me, say 70% more than what you are paying right now. So AWS will take the instance from you. It will give you 2 minutes, and we need to do action in those 2 minutes if we have some workloads running on that spot instance. And of course, in the end, AWS utilize those spot instances and give that compute as an on-demand capacity to a specific client who needs it. As simple as that, but it's not easy when we want to have all these factors together in a Kubernetes cluster. There are some handlers that we need. So talking about the spots, what kind of workloads we can have in the spot instances. I will say that never have stateful applications. Always try to go for stateless application, because in 2 minutes, if you have some data, you cannot migrate from a persistent volume claim, or if it's a cache within the pod. So if you have some stateless workloads that doesn't need any persistent, for sure, try to run those workloads on spot instances. And in a second way, you can say that workloads which are flexible, which have lesser SLAs, or you have just specific migration script which runs in the night, or some jobs, cron jobs which runs in the night. So you can use those workloads to run on the spot instances. There are some examples. You might disagree with CI/CD, but say for the developer, CI/CD for the development environment, of course I can run it. But if it comes to the production, I will never want that something I'm deploying in production and spot instances takes away and I'm in the middle of it. So I will never run my production, but production CI/CD in spot instances. But for dev and say non-production or QA, it doesn't matter. If my pipeline fails, I can recover it. Stateless web servers for rendering development workloads, for sure. Okay, so that's the important topic. Let's go into the feature of the sports, how we can use them in Kubernetes, and what are the main tools and the operators which can help us. The first step is installation of the EKS. This is very important because we will create an auto-scaling group. In the auto-scaling group, we will give some labels. And in those labels, we give in a specific way so that the node will have that label and a taint according to the labels that we define in our infrastructure code. After your EKS cluster is ready, we need to install some say operators. I will call them operators. So first is autoscaler. Everyone knows about it. Amazing tool. It autoscales your nodes depending upon how much load you have right now, and it has a very nice algorithm. You can customize it as much as you want, but right now, most of the workloads you have seen that you give label to your autoscaling groups for the cluster autoscaler, and it behaves based upon those labels of the autoscaling group, and it decreases the total number of compute instances on that autoscaling group depending upon the load. Then there is interrupt handler. This is another tool which can help you to get the signal when AWS sends a signal that they are going to take the instance from you, from the metadata server. Interrupt handler keep on fetching the data within 10 seconds. You can configure that also. And the moment it will get that signal that yes, instance is going to terminate in 2 minutes, interrupt handler will start evicting the pods on that specific node, and also cordon the node so that no new workloads can schedule on the spot instance which is about to die. And once these two tools are ready, we can start pushing our workloads depending on a specific node selector labels or a tolerations or node affinities, depending upon what you like. This is simple flow. You can see cluster autoscaler knows which node to bring up from a specific autoscaling group to match the demands. Yeah. Then it goes to autoscaling group. Autoscaling group used to create the on-demand and spot instances depending upon the labels. Cluster autoscaler will automatically scale ASGs depending upon, of course, they have labels and depending upon the load. Then spot instance handler will take care which node is going down, and accordingly it will take decisions to evict the pods and to cordon the node. This is just to summarize again how we can, what autoscaler can do, what autoscaling group can do, what is interrupt handler is doing. The most important thing is interrupt handler for me. Autoscaler you might have already worked in some of your projects for sure. So interrupt handler identifies which spot instance is being reclaimed depending upon the metadata server configuration, and it prepares gracefully to terminate the node. And of course, it will cordon the node. It will evict the pods depending upon that specific signal. And I will just try let you think what happened. So these are three tools. So what do you think? How to identify that a spot instance is going down? So how to identify? Of course, we have spot instance interrupt handler is an operator which keeps on reading the metadata server configuration, and it will find it out from the status that it's about to die. It's about to die. It has it has a lot of configuration. One of them is in how much time it can go and check the metadata server settings. So this is configurable. You should do it according to your environments or according to your organization needs. How to gracefully prepare the nodes or ports for termination. And again, it's the instance interrupt handler. It will shut down. It will evict the ports. It will shut down. The shutdown will say, I can say that shutdown will happen automatically, but it will cordon the node so that during that time when the node is going down, no new workloads can schedule. Scheduler should not be able to schedule those workloads on a dying spot instance node. So that will be responsibility of again interrupt handler. How to let Kubernetes scheduler new node to schedule pods. I already talked about this. It will cordon. You can see during those specific 2 minutes that you will not be able to schedule your pods on that node, even if there is a spare capacity on that, because it's cordoned off. And there is a cluster autoscaler who will automatically create delete EC2 nodes depending upon the load. It's very nice right now. AWS gives you option of spot fleets, so you can choose depending upon your workloads whether they are compute optimized or memory optimized, and depending upon those workloads you can choose your nodes in the spot fleet, and you can play with it. So again, cluster autoscaler will take care of that. We have some ports which are coming compute optimized, so automatically it will try to fetch that specific instance if it's available, of course. Initially, I have shown you this slide, and I was talking to you about that spot instance interrupt handler is one of the main components. And here, if you will see that it's going down, I will tell you it's some, say in last December, AWS came up with something new, and now we don't need to worry about those 2 minutes when the spot instance is dying. We can create a node groups. I will talk about it in the next slide, few slides. I think that is clear. These are the important operators we must look into before we plan the infra. So infra is again first thing that you need to create, and how to create infra, which is important because you need to make your EKS ready with spot instances and the workloads that can run on it. We need to create a ASG for sport instance. We can give some labels for the node selectors. We can give again taints on the sport instances. We can give taints on all the nodes, but of course we have sport instances, so taint them also. Depending upon these labels and taints, workloads should have tolerations and node selectors. I will show you the code later on. And of course, how to do that. Maciej was also already talking about CDKs, CloudFormation, and Terraform. So just deploy. I use Terraform, and there is a sneak peek of the code. You can see that we are creating a tag. Okay, let me show you the code. No problem. We have a code for EKSTF. So I think you can see it, right? I can go to the full screen if you are not able to see it. So
I think it's fine.
Okay, perfect. So I'm creating a EKS module. This is open source module for Terraform managed by the community. No problem. You just give your parameters, call it, and this is where the magic is happening. So I'm creating my launch template, and I'm creating a name. I'm giving it a spot depending upon the key in availability zone. So test availability zone A sports, test B dot sports. So I will have 3 templates in 3 availability zones. And here I'm giving the extra argument, you can see, to the kubelet, which is lifecycle equal to EC2 node.kubernetes.io lifecycle equal to spot, and register with this. This is very important parameter, and then you will give the tags. So this one, and then the label will be lifecycle equal to EC2 spot. I'll show you that also. And similarly, a taint will have lifecycle equals to EC2 spot, no schedule. So these are the important things. So say this is a auto scaling group you are creating for sport, and if you have some on demand, you can give a different tags. So label lifecycle equals to on demand, and depending upon that, auto scaling group will behave, and you will schedule your workloads to specific node. And how it happens, I will show you something. Okay, so so I think my nodes are going down. No, I still have one node. Can I refresh this? Just refresh me. Okay. What was the lifecycle equal to EC2 lifecycle EC2 spot? Okay, he's saying that no node, but I have one node. I can see that I have one node here. Oh yes, it is showing. So you can see, I just want to show you. So this is my, you can see that this is the label that I gave via my code, and this is the code. You can see that. Okay, sorry, this is for the taint, and this is for the label. So I have shown you. I have my repo already. I will share with the. I will share it with you guys after that, and you can see all the code. Okay, so this is said and done. Let's go again to my slides. Sorry for that. Okay, and in the AWS, when you will go for the auto scaling group, you can see the same labels that you have given, or the tags that you have given in your code. When you will go and check your node, you will have this lifecycle EC2 as a label. You can see that this is a label here, and this is a label on your node. And in the workload, when you will define a workload, I will show you my deployment also in a while. And of course, you define in your workload that what do you want. I want this deployment to go on lifecycle onto the node which have this label. And of course, if you want to give toleration, you can give it, or a node affinity. I will show you demo now. So let me show you my code. Okay, so I use customize. So you can see it's going to Nginx here. In the Nginx, there is another customize who uses these 4 resources. And then I have my deployment. So in the deployment, you can see that I have a node selector, which I already shown you that I have one node which have this label. I have tolerations, the same toleration that I defined in my code, which is my EKS here. I can show you. So this is the same toleration. EC2 support, no schedule, and lifecycle. So this is the taint on my node, and this is the same toleration on my pod. And this is the affinity. So I'm giving the hard. You can also go for the soft affinity, but I'm going for the hard. It doesn't matter because right now, as you have seen, I have only one node. So it doesn't matter. All the ports will go in this node. So let's do it. Control C, Control. Okay. I will delete my deployment, which is already running. Nginx. Okay. Perfect. I have no pod minus namespace default.
Yeah, Sandeep, could you maybe make it a bit bigger?
Okay.
That will be more visible then.
Is it okay?
Perfect. Thanks.
Okay. And this also I will go. So you can see that I have no pod. Oh, sorry, this namespace name is different. FAULT. I have nothing. So I will just, okay, let's go and say diff run. This is my, we use KApp. So KApp is another tool which helps with the customize. We don't use Helm chart at all. Sorry, let me run it again. I don't want to show the name of my cluster. Okay. Come on. Yes. So you can see that it will create one deployment and it will create one HPA. So let's go back to our code. So this is the deployment and this is the HPA. So you can see that I have minimum 10 replicas and 20 replicas. I did it just for the demo. I will have 10. So let's go and run it and see the magic here. Okay. So I'm watching the pod on my namespace. When it will be ready, KApp will start deploying them. Okay, so they started coming. You can see that. And it's running. This container is creating Nginx. Okay, it will create, but you will ask me now it succeeded. How do I know that it's running on the node, which is a spot instance? So just go -o wide. Okay, check this, the node name. They are all on the same node. I have just one node name, and you can see this is the node, and it has a label lifecycle equal to EC2 spot. So right now I have only one node, which is on spot instance, because I do not have a lot of loads. It's already evening, and we normally shut down all our workloads at this time. So you can see that my Nginx or any workload, it's running on an instance, which is a spot instance, and via a specific way. When I define my deployment, I just need to take care of these parts. So whatever you like it, a toleration, a taint, of course, taint, or toleration, or a node selector, or a node affinity. And you can run your workloads on the spot instances. I will go back to my slides. Wait for that. Okay. Yes, this is very important. Some time ago, I shown you that we don't need a spot instance interrupt handler. So recently in December, during the time of reInvent, I think EKS announced a node group for spot instances. So if you have a node group, the heavy lifting will be done by the node group, and building and maintaining configuration for spot instances in EC2 auto scaling groups, it will be done by node group. Deploying a tool for handling spot interruption handler, you don't need to install this interrupt handler in your Kubernetes cluster. It will be handled by the node group. Any updates on the AMI, of course, that will be the part of that, and a specific kubelet version you want to run on worker node. So everything will be handled by node group. This is the article, and I will share my slides. It's amazing article, very big one. If you really like it, how to run your workloads on spot instances in future, you should go it. You should just read about it. It's amazing. But right now we have not moved to node groups because, as I already told you, we are still using Terraform and there is no support for node groups for spot instances in Terraform yet. It will come and we will move all our code from what I have shown you to the node groups. Workarounds, of course, if you want, you can go for CloudFormation, CDKs, whatever you like. But we specifically use Terraform, TerraGrunt, tech stack, and whenever it is available, we will start using it. If you have any questions, Maciej, I think we can go after them.
Perfect. Thanks. Thanks a lot, Sandeep, for the presentation. So, guys, if you have any questions, just type them into the chat. And yeah, one thing, if you do the quiz, just please remember to include your email address, because, well, we somehow need to send you the price and link to either the discount, or, well, we need to have somehow contact with you. So please insert your email address into that quiz. We have one question. So let me read it. So we have a question from Mitura. What do you use? What do you use to run Kubernetes on-prem?
Okay, so there are some 1 or 2 variants as far as I know. We do not use personally, but I know what other guys are doing. So they have Puppet modules, and with the help of those Puppet modules, they deploy their control plane and worker nodes plane, you can say. On-prem, we have very few clusters, not that much. And then there is something from VMware also. I'm not aware how they are doing it, but of course they are VMware itself gives you some box which you can run on-prem. I never worked on it. I know the guys are using in my company, but I never worked on them. For me, the whole Kubernetes is AKS or EKS, only in the cloud. So if this is what, yeah.
Okay. Thanks, Sandeep, for your answer. Are there any other questions to Sandeep related to that? Just type them. If not, okay. I have actually one question for you. So, yeah, sure. Have you seen like customers moving to that solution running on spot instances from on-demand? And what are the usually the costs going down, if you have any numbers like percentages that you can save doing this?
Okay, so first things first, I do not have the numbers right now with me, but when the task come, when the architect came and he said that we have a facility to use spot instances, so we started using it, especially the workloads which are stateless for us and which can easily sustain the flexibility of killing. So we don't mind, because we have spreaded those workloads in all the availability zones. So even when availability zone is down, so we know that it will not affect the functionality. So those workloads we have shifted, and for sure that compute is being used from the spot instances. So prices definitely might have gone down. I don't know the figures, to be honest.
Sure. Thanks for the answer. That's really good. Yeah. I've seen myself drop of cost, of course, when you use spot instances. But well, as you said, you have to have the right application to be able to run and survive this kind of interruption.
Correct.
Okay, I don't think we have any more question. So again, thank you guys for the presentations, and well, we will see you next time on the next AWS user group. Wait a second, we actually have more questions, so let's maybe answer them before we'll go. So Maciej actually is asking, do you use spot instances in production?
For one of the specific cluster, yes, we use, but not for all the clusters, because in that clusters we have those workloads which can sustain a killing. Okay, so shutting down of the port. So I'm reading the next one. Yes, we are using in production, but not that fully, if you are asking.
Okay. And what about that space is asking, what about the data transfer between availability zones, in this case, when you are spreading workloads among various AZs?
Yeah. Of course. You are right for sure, data transfer. I never thought about it, to be honest. Yes, there are costs attached to the data transfer if there are different availability zones. But for me, say as a business point of view, for me, most important is reliability of my service or the availability of my service. So if everything is one availability zone and everything is dying, or that spot instance is dead, or that availability zone is gone, so for me, that money is not, will not help me if my users will complain. So better to spread your instances in all the availability zones just for the higher reliability and availability. I think this is what my architects and my company believes in.
Yeah, I agree. It always depends on the business and the importance of your workload. It's if you can, if it's important that this service is available all the time, or like it has high availability, then well, you need to consume the costs. And another question we have from Carolina. What is your opinion about EKS Anywhere? Will this make easier moving apps between clouds and on-prem?
Oh, if you are just asking about the opinion.
Yes.
It's hard to say. Yes, there are pros and cons for sure, EKS Anywhere. And if you have some workloads, I will try to say in that way that if you have a team which is not so much, say, cloud ready right now, or they know not that much about Kubernetes or cloud stuff, in that case, something in on-prem can help us to move gradually to the actual cloud. So if you will say that on-prem clusters, because we are maintaining, this is one thing I can think about it. Second is, of course, on-prem clusters control plane is very hard to manage. I am administrator of Kubernetes since a long time, and it's very hard. So if you have some control plane which is already ready to use, like our Mithura is saying that this Tanju, and something like EKS on-prem, if you have control plane ready, then why not use it rather than managing your own Puppet modules and upgrading every time yourself the whole control plane with every 3 months a new Kubernetes version comes up. So that can be For me, I'm not much opinionated about that. So this is what I feel actually. This is not opinion, actually, but this is what I feel about both of them, pros and cons.
Sure. Yeah. Thanks, Sandeep, for the answer. And let's see if we have anything else. I think for now that's it. If anything else will come, we can always answer it directly on the YouTube platform. Thanks for the participation, and thanks for the great presentations, and see you soon.
Thank you everyone for your time. Have a lovely evening.